We're looking at graphing equations, and in the previous two videos we talked about graphing linear equations. That is, for example, y is equal to x plus 1. Okay, that means this has a power of 1 right here, but we don't write it. Let's take a look at some higher order ones, like, for example, y is equal to x squared. Y is equal to x squared. Okay. Y is equal to x squared is going to be what's called a parabola. It's going to look something like this. Now, take notice what I just said. It's going to look something like this. Okay, so I'm attempting, and it's usually the way this software works. It's usually graphed out like that. It'll go from here to here, but anyway, this is just going off to infinity, and this is going off to infinity here. Unless we state otherwise, right? Unless we give it some domain restriction on the domain there. But the parabola looks something like this right here. Y is equal to x squared. Imagine what y is equal to negative x squared might look like. In other words, you would take this point right here on the line, and you would make the y negative. In other words, you'd get reflected about the x-axis. So each one of these points would get reflected about the x-axis. Once again, over here on the left, so you'd have something gets reflected, something that looks like this when we throw the negative inside. Remember when we graphed y is equal to x, and it was a line that just ran through the origin and went up in this direction? But when we graphed y is equal to negative x, right, what happened to this line? It got reflected. Each point on the line got reflected back down. See? It's a reflection. And in the next section, we're going to talk about this, called symmetry. Okay, testing for symmetry. We're going to be looking at the symmetry of these graphs. But right now, we're just kind of looking at their behavior and getting familiar with that. Now, the best thing I said to do is to definitely bring up, I'm using DESMOS. DESMOS, okay, you can just Google that, and it's really a good website to do your graphing on, learn how to graph. So let's take a look at this. So remember, this was y is equal to negative x. Let's just go ahead and graph. Let's graph y is equal to x once again. So you see, if you looked at this point right here and you took the negative of it, the y value, okay, the y coordinate, the negative, what happened? Each point gets reflected, right? Which makes up y is equal to negative x. Now let's go ahead and get rid of those, and let's do y is equal to x squared. Right, follow up what we were talking about earlier, that I was attempting to draw this graph. This is y is equal to x squared here. How about y is equal to negative x squared? Remember what that looked like? Y is equal to negative x squared. See that? So it got reflected about the x-axis here. See, it looks like a reflection. Pretend this is all water down here. See that? Got reflected. Okay. So that's y is equal to negative x squared. All right. What happens when we add 1? Let's go back. Let's just look at. Let's move this down a little bit. Let's look at y is equal to x squared. When we add 1, okay, look what happened. The thing got shifted upwards. Let's actually. Let's do this. Let's see here. Okay, so the orange, this was our original, y is equal to x squared. We added 1. What happened? It got shifted upward 1 unit. See that? What if we wanted to shift it to the right? I want to shift this graph to the right. What do you think we'd have to do? Shift the whole graph to the right. Let's say over here to 2. What do you think we'd have to do? Let's see here. plus 2. So we're just playing around with this stuff. Okay, we're going to have to, I guess we're going to have to, it's going to make it start over here. So we're just exploring. I think it's plus 1. Then squared. Oh, it went to the other direction. It went back in this direction. I was wanting to shift it back in that direction. Let's bring this up. So let's just clear this out real quick. So our graph was running, so this, we're going to say, okay, this is y is equal to x squared. We wanted to move the whole graph to the right to here. Shift the whole graph. Now we ended up shifting it in this direction. The reason it went in this direction, this is what it looked like. Okay, x plus 1. So think about that. If I were to plug in 1 into here, this needs to be 0 because remember it's getting shifted. Okay, so if I plug a 1 in to here, the y value needs to be 0. But if I plug 1 into here, what do we get? You see, we end up getting 2 squared. We get 2 squared, which is 4. So that's the reason this thing got shifted over 1 unit, because when I plugged 1 in, let's go back. When I plugged 1 in right here, see that 2 squared is 4. See the 4 right here? Okay. We want the graph to be shifted in this direction. So what we're going to have to do is, instead of x plus 1, this will have to be x minus 1. Okay, so we plug 1 in now. 1 minus 1 is 0. Okay, they call this part of the parabola here the vertex. Right, this is known as the vertex right here. Okay, so this becomes x minus 1. Well, anyway, let's go back to the graph. Let's take a look at some other graphs. There's all kinds of graphs we can make. What about y is equal to x to the 3rd power? Let's take a look at this. Y is equal to x to the 3rd power. Look at that. What is that doing? See that? Y is equal to x to the 3rd. Now, if we wanted to shift the graph up, we would just add 1 to it. Add 1. See that? Shifted the graph upward. If we wanted to shift the graph downward, then we would subtract 1. Y, or x cubed minus 1. See that? What happens if we want to shift the graph to the right? Now, we just talked about this. Or shift it to the left, right? We'd have to substitute that x and put x minus 1 if we want to shift it to the right, or x plus 1 if we want to shift it to the left. Okay. Let's take a look at some others. That's yx cubed. What about y is equal to x to the 4th power? Now that almost looks like a parabola again, doesn't it? But it's not. It's more flatter here. See how flat this is? Okay, this is y is equal to x to the 4th. Now you notice, let's make some observations here. Remember x squared came from up here and then went back up? Then we did x cubed and it came from down here and then it went up. And now we're at x to the 4th and it's coming from up here then going back up. Do you see a pattern yet? What about y What about y is equal to x to the fifth? What is that going to do? Y is equal to x to the fifth. That almost looks like y is equal to x cubed, doesn't it? Y is equal to x cubed. So you need to be paying attention to these patterns because they're going to be important when it comes to graphing equations. So you're going to be given an equation. You should be able to take a look at it and go, oh, I have an idea of what the graph at least looks like in my mind. All right, let's take a look at some. These are let's take a look at some other ones here. I was going to say what type of equations these are, but I'm going to leave that for later. All right, let's take a look at 1 over x. We can graph that. Y is equal to 1 over x. Whoa, what is that? Y is equal to 1 over x. What happens if we want to shift that graph up 1 unit? See, that shifted it up, or we want to shift it down 1 unit. Shifted the graph down. That's y is equal to 1 over x. We can even graph things like absolute value. Remember doing absolute value equations? Here's the y is equal to the absolute value of x. Look at that. Y is equal to the absolute. Why is it? Got no negative values. Now we wanted to shift it up 1 unit. See, we shifted it up. Or we want to shift it down 1 unit. Okay, what about if we wanted to shift it to the left or to the right? Remember what we should do? Okay, so I would the best thing to do here is this is a good website here if you got a graphing calculator, is to just play with this stuff. Type stuff in and take a look at the graph. Okay, and try to see patterns. Try to see patterns. Let's look at one more before we go. How about the square root? Let me see if I can do that. Here's y is equal to the square root of x. Y is equal to the square root of x. I know that I haven't been writing these on the screen as we've been going. I'm just listening to my voice. Yeah, we're having some problems here again. Okay. So y is equal to the square root of x. What does that look like? It looks like this. Right? This is y is equal to the square root of x. Okay. Now if we wanted to shift this graph up, we would say y is equal to the square root of x plus 1. That would be shifting it up 1 unit. So it would be looking like this. See that? What if we did this? Y is equal to negative square root of x. What does that do once again? Remember, we throw a negative out here in the front. It's going to what? You're going to get a reflection. See, that would be the reflection of this graph. So once you understand what that looks like, when they throw a negative out front, then you'll know it's just a reflection. Okay? Or if we add some constant onto the end, we know that it's going to be shifted up or down. Or what if we did this? Y is equal to x plus 1. Remember what happens here? This is going to get shifted to the left because we plug negative 1 into this. Negative 1 plus 1 is 0, so we know that we'll have to start here. See that? If we plug in 0 in here, x is 0, this is going to be where it crosses the y-axis, so the square root of 1 is 1, so we know it's going to cross right here, so we know that the graph is going to look something like that. Okay. All right. 14 minutes. Man, I've gone way too long here. All right, so this is where we are. In the next section, we're going to end this. You need to get over here, start typing stuff in, playing with it. Okay, this should at least get you started. And in the next section, we're going to talk more about finding the y and x intercepts. And we're going to talk about this symmetry, because knowing the symmetry of your equation is going to really help you be able to simplify problems in the future, and help you graph this stuff out. All right, symmetry is extremely important. All right, and I'll see you there.